Hey guys, welcome back. Unfortunately, I can't be here again today, but we're going to try this video thing once more and see how it goes. The plan today is to talk about some X-Intercepts and look at some word problems. Before we get started, your warm-up is going to be up on the board, 5 minutes up on the clock, and then we'll go through the answer. Okay, time's up, so let's go over the answers. So again, we talked about this yesterday, how to find the equation of these parabolas. So in order to do that, we're going to start off by putting it into vertex form. So we find our vertex on our parabola, and it's here at -5, 9. So from there, that's our h and our k value. So when we go into our parabola, we say y equals some a value times x minus h. So when we minus -5, we get +5 squared, and then plus k, so our 9. So our x value goes in here, the y value of our vertex goes there. In order to find the equation, you need another point. So in this case, the other point is -4, 4. So again, we talked about two strategies yesterday. Strategy number 1 is to use transformations. So again, we're looking at the parent function y equals x squared. For that function to move 1 unit over from my vertex, so originally my vertex is at 0, 0, right? 0, 0. So to move 1 unit over, we would move 1 unit up, because if we were to take the number 1 and square it, we get 1. To move 2 units over, we'd move up 4, because again, 2 squared is 4, 3 units is 9, and so on and so forth. For this new function, however, when I move from -1 to -4, that means I'm moving 1 unit to the right. I go from 9 to +4. So that means I'm moving 5 down. So if we compare our parent function, where we went over 1, up 1, this time we're going over 1, down 5. So right away, I know that my new quadratic has to be negative because it's opening down instead of up. But what is the value of a here? Again, since we were at 1, and we're now at 5, we know that a is going to be equal to new over old, or in other words, -5 over 1, so a is -5. X plus 5 squared plus 9. And there is the quadratic that describes this parabola. Okay, let's try b. So again, b, we need a vertex, so we have a vertex here at 4, 3. And we have a second point down here at 5, 0. The second strategy we talked about is doing it algebraically. Again, using your vertex form, so y equals a onto x minus 4 squared plus 3, and then plugging in this value for x and y. So since x is 5 and y is 0, we plug them into our equation. So we say y is 0. We don't know a, so we're going to leave it as an a, and we say x is 5. Minus 4 squared plus 3. So then we go through the math here, do some order of operations. So we say 5 minus 4 is 1, and 1 squared is 1, and 1 times a is a, plus 3 is going to be equal to 0. So then when I take the 3, move it to the other side, it becomes negative, and I get a is equal to -3. So my new equation is y is equal to -3 x minus 4 squared plus 3. And I said this yesterday, and I'm going to keep saying it all semester long. You have to develop a strategy that works best for you. And what I mean by that is maybe you can see it better algebraically, or maybe you can see it better using the transformations, or maybe for you it's some combination of the two. But whatever strategy works best for you, I suggest using and getting comfortable with. Okay, so let's take a look at what we're going to do today. So today we're going to talk about X-Intercepts, because last semester when we did quadratics and foundations, X-Intercepts were a huge part of the unit. It's the whole reason why we factor a quadratic, right? If we have a quadratic in our general form where we have y equals ax squared plus bx plus c, well, we factor that quadratic in order to help us find the X-intercepts. But when we have a quadratic that is in vertex form, we can't factor something in vertex form, so what we need to do is have some other strategy to help us determine the X-intercepts. Now, there's a little shortcut. What I want you to do is first determine the number of X-intercepts before actually trying to find them, because it may turn out that you don't have any X-intercepts, and you don't want to actually have to go through the work of trying to find X-intercepts if they don't exist. So how are we going to do that? Well, we have to think about this for a second. When you look at your quadratic in vertex form, we have our vertex, right? We know what the highest point or the lowest point is going to be, and we know the direction of opening. So for example, this quadratic right here, letter A, what is the vertex of this quadratic? Well, it's 4, -18. And what direction does this quadratic open? So the direction is up, right? It opens up. And how do we know it opens up? Because our A value is positive. So what that means is I have some vertex way, way, way down at -18, but my parabola opens up from there. So if that's the case, how many X-intercepts am I going to have? Well, since I have a vertex that's below the X-axis, and my parabola is opening up towards the X-axis, that means I'm going to have 2 X-intercepts. So now, let's try and solve for those X-intercepts. So how do we solve for an X-intercept? And that question is true for any polynomial. To solve for the X-intercept, we always let y be 0. So we're going to do just that. We're going to take this y and replace it with 0. So 0 equals 2 x minus 4 squared minus 18. Now, what our goal is to get x by itself, because once we have x by itself, that value, or those values, are going to be our X-intercepts. Now we know there has to be 2 answers, but there's only 1 instance of x here. So we're going to see what happens here in a second. So in order to get this x by itself, we have to do some inverse operations, right? We have to get rid of all of the numbers from this side by moving them to the other side. So I talked about last semester of using analogy of unpacking a suitcase, right? If we take a look at this x, if this x is on the bottom of our suitcase, order of operations says the next thing that we're going to do is -4. We're then going to take that answer and square it. We're then going to take that answer and times it by 2, and take that answer and subtract 18. So to get x by itself, we have to unpack our suitcase, meaning that the last thing we put into our suitcase is the first thing that has to come out. So the first thing I need to get rid of is this -18. Well, how do you get rid of a -18? We bring it to the other side by adding it. So when we add it to the other side, we get +18. So +18 is equal to 2 onto x minus 4 all squared. Next thing we have to get rid of is this 2. Again, we have to do the opposite. So right now, 2 is being multiplied by our bracket. So to get rid of the 2, we have to divide. So 18 divided by 2 is 9. So 9 is equal to x minus 4 squared. Okay, next we have to get rid of this squared. So what is the opposite of squaring something? And this is where it gets a little weird. So the opposite of squaring something is to take its square root. So right away you're probably thinking, well, the square root of 9, that's 3, right? So we'd say 3 is equal to x minus 4. Well, we have to be careful. When we're doing inverse operations, we're not just taking the square root of 9, we're thinking to ourselves, what number that if I were to square it would give me 9? And yes, the answer is 3, but there's a second number that also does that, and it's -3, right? We have a -3 because if we take -3 and we square it, we get -3 times -3, and -3 times -3 is in fact +9. So there's 2 numbers that if we square them, we would get 9. It's +3 and -3. So now, last thing I need to do to get x by itself is to get rid of this -4, so I'm going to add 4 to both sides. So we get 4 plus or minus 3 is going to be equal to x, so that means x is equal to 4 plus 3, which is 7, and x is equal to 4 minus 3, which is 1. And that makes sense because we're supposed to have 2 x-intercepts, and in fact we do. We get x equaling 7 and x equaling 1. So what that means is this quadratic will pass through the x-axis at the point 7, 0, and at the point 1, 0. Okay? All right, let's move on to B. So with B, I purposely put the 0 here, right? I purposely put this 0 up here. Now, you won't normally see it there, but let's just see what happens. So again, let's think about this for a second. before we do any work, let's find our how many x-intercepts there are going to be. So when I move that 0, when I look at my q value, it means my vertex has a y value of 0. So what that means is that my vertex happens right on my x-axis. So if I were to start graphing this thing, I have a h value of -2, so we're over here at -2, and a q value of 0. So this is what it looks like. So whether it opens up or down, so in this case it's going to open down, so what it's going to look like is something like this, where our parabola just touches the axis right here at -2 and bounces off of it. So for this one, we're only going to have one answer. And let's see why that is algebraically. So again, what I want to do is I want to solve for my x-intercept by letting y be 0. So I say 0 is equal to the negative of x plus 2 squared plus 0. Well, if I wanted to get rid of this plus 0, I'd move it to the other side by subtracting it. 0 minus 0 is equal to, well, 0. So 0 is equal to the negative of x plus 2 squared. Now, I want to get rid of this negative. In order to get rid of a negative, we have to multiply both sides by -1, right? We take the negative of both sides. So the negative of 0 is 0. So 0 is equal to x plus 2 squared. Now again, I want to get rid of this squared by taking the square root. And as we saw earlier, when we take the square root, right, when we're doing our inverse operations, we get two answers. We get both the positive and the negative numbers being an answer. Well, is there a difference between positive 0 and negative 0? And the answer to that is no, there isn't. So when it comes time to taking the square root of 0, we don't have to worry about plus or minus, it's just 0. So 0 is equal to x plus 2. And finally, what that means is x is equal to -2. Because when we move that 2 over, we get -2. So we have an x-intercept at -2, 0. And that's our final answer. There's only one x-intercept, just like we expected. Okay, lastly, this question C. Again, before you do any work trying to find your x-intercepts, see how many there are. So with this one, my q value is positive 8. So right away, that means I have a vertex that is 8 units above my x-axis. So it's somewhere up here, right? Somewhere up here. And the direction of opening for this quadratic is up because my a value is positive. So that means this quadratic is going to open up from there. Knowing that my vertex is already above my x-axis and that my quadratic is opening up means I don't have any x-intercepts. This quadratic will never pass through the x-axis. So why is that? Well, let's take a look at this algebraically again. So let's let y equal 0. So 0 is equal to x minus 3 squared plus 8. So if I take that 8 and move it to the other side, I get -8 is equal to x minus 3 squared. And again, the next step to get x by itself is to get rid of this square. So I'm trying to take the square root of both sides. So I'm trying to take the square root of -8. Well, what happens when I take the square root of -8? If I were to take this and plug it into my calculator spits out an error. There are no answers that you could, there are no numbers that you could square and get a negative value. No real numbers, that is. So even if I knew what the square root of 8 was, which wouldn't be too challenging to figure out, but the fact that this is negative means that it's going to give me an error. So algebraically, what that means, because I get an error, I don't have any x-intercepts. No x-intercepts. Right? All right. So what I'd like you guys to try to do now, just go ahead and pause the video, and I want you to try these questions for me. So once you feel like you've had enough time to attempt these questions, we'll go over some of the answers together. Okay, so hopefully you guys had enough time to try these and find your x-intercepts. So let's go through these together as a class and check your own work, okay? So let's start off with question A. So again, like I've been saying, figure out how many x-intercepts there are first before you do any work, because you might just find that there aren't any x-intercepts and you can just skip yourself a lot of hassle by saying no x-intercepts, nice and easy. So for this question, my q value is negative and my a value is positive. So what that means is I'll have a vertex that's below my x-axis, but I'm opening up, so I'm going to be opening up towards the x-axis, so that means I will have two x-intercepts. So in order to find those x-intercepts, again, what we need to do is let y be 0. So 0 equals x minus 2 squared minus 16. And again, the goal is to get x by itself, so I need to start unpacking my suitcase. So I'm going to move my negative 16 over, and I get positive 16 is equal to x minus 2 squared. Then I need to take the square root of both sides, and the square root of 16 is 4. But again, don't forget, we're looking for all possible numbers that if you were to square them, it gets you 16. So not only is 4 an answer, but negative 4 is also an answer. So plus or minus 4 is equal to x minus 2. Then I take the negative 2 and I move it over, so I get negative 2 plus or minus 4 will be equal to x. And that means x is negative 2 plus 4, which is 2, and negative 2 minus 4, which is negative 6. So I have x-intercepts at 2, 0, and negative 6, 0. Make sense? Well, hopefully. All right, next one, B. Now, it does not matter if you have fractions or decimals or whatever the case may be, right? We still have to deal with this exactly the same way. My q value is negative, so my vertex is below the x-axis. My a value is positive, so we're opening up. So let's do that. That means we have two x-intercepts. So let's solve. 0 is equal to 2x plus 3 squared minus 9 over 2. Let y be 0 and solve for x. Move the 9 over 2 to the other side by making it positive. 9 over 2 is equal to 2 onto x plus 3 squared. Divide both sides by 2 to get rid of the 2 that's in front of my bracket. So 9 over 2 divided by 2. 9 over 2 divided by 2. And what I'll do is I'll take that and maybe move it over to the side so you can see. How do we do 9 over 2 divided by 2? Well, we have to turn it into a fraction and flip it and multiply. So 9 over 2 divided by 2 is the same thing as 9 over 2 divided by 2 over 1, right? 9 over 2 times, we flip the 2 over 1 and we get 1 over 2. So 9 times 1 is 9, and 2 times 2 is 4. So 9 over 4 is equal to x plus 3 squared. Okay, again, what we need to do is take the square root of both sides. Well, the nice thing about this number here is that this is, in fact, a perfect square. 9 is a perfect square. 4 is a perfect square. So 9 over 4 is a perfect square. So if we take the square root of 9 over 4, we get 3 over 2. And again, because there's two answers here, one positive, one negative, is equal to x plus 3. Let's take the 3, move it to the other side, so we get negative 3 plus or minus 3 over 2 is equal to x. And then it's just a matter of adding to find our two answers. So negative 3 plus 3 over 2, we would use a common denominator, right? So negative 3 is negative 6 over 2. So we get negative 6 over 2 plus 3 over 2, which is negative 3 over 2. And negative 6 over 2 minus 3 over 2 is negative 9 over 2. So again, we'd have x-intercepts at negative 3 over 2, comma 0, and negative 9 over 2, comma 0. All right, next one. Notice here there is no q value. So in fact, the q value here is 0. So what that means is this parabola will have a vertex right on my x-axis. So what's going to happen is it's going to touch my x-axis and it's going to bounce right off. So just like with the last time we saw that happening, there's only going to be one x-intercept here. So let's solve. 0 is equal to negative 3 x minus 1 squared. Right, if we divide both sides by negative 3, well, 0 divided by negative 3 is 0. So 0 x minus 1 squared. The square root of 0 is 0, so 0 is equal to x minus 1, and x is equal to 1. Now, we could have taken a little shortcut there. Knowing that our q value is 0, it means our vertex is the x-intercept. Well, we already know how to find the x-intercept. We know the h here is 1, so what that means is I have an x-intercept at 1, 0. And it's just one x-intercept this time. Okay, last question. So again, how many x-intercepts will I have? If I move that if I look at my q value of negative 32, means I'm below my x-axis. My a value is positive, so we're going up from there. So we should have two answers. So let's solve. 0 is equal to x minus 3 squared minus 32. Bring the 32 to the other side, and I get 32 is equal to x minus 3 squared. And then if I take the square root of both sides, something happens here. Well, 32 isn't a perfect square, so how am I going to deal with that? Well, I deal with it same way as I would anything else, but we're just going to leave it as a radical. So the square root of 32 is plus or minus root 32 is equal to x minus 3. Now, root 32 isn't the nicest, so what I'd want to do here is I'd want to simplify it by finding the largest perfect square that goes into 32, which is 16, and then simplify that, so the square root of 16 is 4. So this turns into 4 root 2, because 4 squared is 16, and 16 times 2 is where I got the 32 from, is equal to x minus 3. And again, let's move the 3 over, and I get x is equal to 3 plus or minus 4 root 2. And those two values would be my x-intercepts. Now, you could plug that into a calculator and get a decimal, but this is the most accurate answer you're going to get. As soon as you start rounding off, we start losing data. So we're going to leave it just like this. Okay. So the last thing we need to take a look at before I let you guys work on your own is word problems. The nice thing about quadratics is that we actually see them in the context of the real world quite frequently, right? Like we see these shapes, these parabolic shapes all the time. So what we can do is we can apply them to help us solve questions like this one here. So let's take a look. The longitudinal section of a canyon makes a parabola shape that has the equation y equals 2 onto x minus 3 squared minus 18, where x and y are measured in kilometers. How wide is the canyon and how deep is the canyon? So how wide is the canyon? Well, in order to figure out how wide the canyon is, what we need to do is we need to figure out the distance from this point here to this point here. Well, what are those points? Those points are your x-intercepts. So if I can find the value of this x-intercept here, and I can find the value of this x-intercept here, I would just subtract them to find the distance between them. So let's do that. Let's do what we've been doing to find our x-intercepts and solve. So how do I find my x-intercepts? I'm going to let y be 0. So 0 equals 2 onto x minus 3 squared minus 18. Okay, take the 18 over the other side, and I get 18 is equal to 2 onto x minus 3 squared. Right, come over, divide both sides by 2, and I get 9 is equal to x minus 3 squared. Take the square root of both sides, and I get the positive and negative 3 is equal to x minus 3, and finally bring my 3 over to the other side, and I get x is equal to 3 plus or minus 3. Well, 3 plus 3 is 6, and 3 minus 3 is 0. So what that means is I have an x-intercept here at 0, 0, and I have another one over here at 6, 0. Okay, so what that's telling us is that our canyon is how far apart? Well, if I take these 2 points and find the distance between them, or 6 minus 0, I get a distance of 6 kilometers. Okay, secondly, how deep is the canyon? Well, we don't even have to do any work for this, really. We already know the vertex, right? We know the values of the vertex. The vertex is the bottom of the canyon, right? It's this point right down here. So what I can do is I can use my vertex to help me answer this question. So what are the coordinates at this point? Well, we look at our h and our k value, and we say that this is 3, negative 18. So in the context of this question, what does negative 18 mean? Well, negative 18 means that we are 18 kilometers down from the lip or the edge of my canyon. So in other words, my canyon is 18 kilometers deep. Right? So we have a canyon that's 6 kilometers wide and 18 kilometers deep. And there we go. Okay, last question before you guys get to try some of these on your own. So what I'd like you guys to do is to try this one by yourselves first. So pause the video for a couple of minutes, and then once you think you've had enough time to go over to get an answer, then restart the video and we'll go over this together. So suppose a parabolic archway has width 280 centimeters and height 216 centimeters at its highest point above the floor. Write a quadratic function in vertex form that models the shape of this archway, and B, determine the height of the archway at a point that is 50 centimeters from its outer edge. So what we need to do is we need to find a function first that's going to model this parabolic shape, right, this parabola. Then once we have that function, we can use it to solve for part B. So for part A, we need to find the equation of the function. So what we're going to do is we're going to, just like we have been, look at the information that we're provided and try to find the vertex. So what you'll notice is that there are different ways that we could put the parabola, or different ways we could put the Cartesian plane on this parabola. We could have our xy axis right here at this point, right? Right here at this point here, right? Or we could have had it up here at that point, or we could have it over here at this point. So there's a lot of different equations that are going to describe this parabola, but I would argue for this question the easiest place to put it is right here, where it gives us an x-intercept here at 0, 0, and it gives us another one here 280 units away at 280, 0. What that means is that our parabola, because parabolas are symmetrical, our vertex is going to be here right in the middle of 0 and 280. So our vertex here is at 140, 216. Okay, well from here, let's start writing in our information. So y is going to be equal to some a value times x minus 140 squared plus 216. So now it's just a matter of solving for a. Right, so to get a, we have different strategies that we can use. We can either apply transformations, or we could use one of the other points in for x and y. For this one, because the numbers are so large, it's probably easier to just do one of the other points instead of trying to do the transformation. So let's do that. So let's use the point 0, 0, because that's arguably the easiest point here. So 0, 0, so 0 equals a onto 0 minus 140 squared plus 216. So what that means is 0 is going to be equal to a onto negative 140, right? 0 minus 140 is negative 140 plus 216. We square negative 140, so 140 squared, and we get 0 is equal to a onto 19600 plus 216. So now we're trying to get a by itself. So the first thing we're going to do is we're going to move the 216 over, right? So we get negative 216 is equal to 19,600 a. Divide both sides by 19,600. So 216 divided by 19,600 is going to be equal to a. And what that means is a is going to be this simplified. So if we simplify this a little bit, we get negative 50, sorry, negative 27 over 2,450. So what that means is my equation is a equals negative 27 over 2450 x minus 140 squared plus 216. Now, what I can do with that is I can use my new equation to help me find answer B. Because what we're going to do is we're going to take this 50, we're going to plug it into our equation for x, and that'll spit out our answer y. So question B, we're going to use our new equation, and we're going to use the value 50 in for x. So we're going to say y equals negative 27 over 2450 times 50 minus 140 squared plus 216. All right, so we're going to take the 50 and subtract it from 140. So 50 minus 140 is negative 90. All right, we're going to take negative 90 and we're going to square it. And then we're going to take that answer and multiply it by negative 27 over 2450. So when I do that, grab my calculator. So I get 50 minus 140, take that answer and square it, and take that answer and multiply it by 27 over 2450, and we get negative 89.27 plus 216. When we add that to 216, we get 126.7. So what that means is when our archway is 50 centimeters from this edge, it's going to be 126 centimeters above the ground. Now, what about the other edge? Because the question doesn't specify which edge. It just says 50 centimeters from an edge. Well, the nice thing is, because of the way we've set up our parabola, 50 centimeters from this edge is going to be symmetrical to 50 centimeters from that edge. So they should be at the same height. All right, so what I'd like you guys to do now until the end of class is to try some of these questions. So question 4, I'd like you to sketch. Right? Question 8, I want you to find the equation for this parabola. And finally, question 21 down here is a little different, but I think you guys can handle it. Okay, so I'll be in tomorrow. If anyone has any questions, we'll go over these tomorrow. We'll take a look. Again, come to class tomorrow ready for a warm-up. Okay, have a great day.